right, number 10, consider the graph of that. Write down the domain and the range. Well, I'm going to start with B because the horizontal asymptote is going to be y equals 6 over 2. Remember, it's the ratio of the coefficients, so y equals 3. And that means the range is y can't be 3. The vertical asymptote is when the denominator is equal to 0. So we're going to have x equals 2, which means the range is x can't be 2. Now the x and y intercept for C, we have, for the y-intercept, we want to make x 0. So when we do that, that's the x's are going to be 0. So it's 0 plus 1 over 0 minus 4. And for the x-intercept, we set the numerator equal to 0 and solve. So that's x equals negative 1 over 6. All right, 11, write down the domain and range in the horizontal vertical asymptote. So the horizontal asymptote, because we have a smaller degree up top, this is x to the 0 over a larger degree, x to the 1, the horizontal asymptote is 0. Y equals 0. Vertical asymptote, still the denominator equal to 0. So we have x equals 2, which means the domain is x can't be 2, and the range is y can't be 0. X and y intercept, so we would do f at 0 for the y-intercept, and that's going to be 6 over negative 4, so negative 3/2. And if we set this equal to 0 to find the x-intercept, you cross multiply by the denominator, so that just goes away. So you set the numerator equal to 0, and clearly 0 does not equal 6, so there is no x-intercept. For number 12, we've got f at x as shown in the graph with the x-axis as an asymptote. Okay, so as x gets really, really large, the function approaches y equals 0. Okay, on the same axis, draw the graph of that, indicating the coordinates of A and B. So we are going left 2 and down 3. So left 2, down 1, 2, 3, this is B. And left 2, down 1, 2, 3, this is A. And also the asymptote goes left 2, which makes no difference, and down 3, so that's going to be at negative 3 here. I'll do a dotted line. So then we have something like, and then it intercepts there. So we have something like this. Okay? All right. So write down the equation of the asymptote. So this one is still the same. Y equals 0. It's just moving left 2. It does nothing. But this brings the asymptote down to negative 3. And this also, the left 2 does nothing. And the minus 3 brings it down. All right, for 13, the graph of the function, we've got a negative 1, 1 there. And we have y equals negative 1 is the horizontal asymptote. Okay, so G is that on the diagram, sketch G. So we are going right 1 and up 2. So this is new A. And asymptote goes right 1, up 2, which makes no difference. So this is the new asymptote, and it's looking like something like that. It's not great. But, yeah, you get the picture. All right, write down the equation of the horizontal asymptote of G. So that's going to be y equals 1, because the asymptote has moved up 2. So A prime, A dash, be the point on the graph of G corresponding with A, write down the, so we've already done that. It's 0, 3. Write down the equation of the horizontal asymptote. So this is just dividing the x's by 2. It's a horizontal compression. It does nothing to the horizontal asymptote. But this one multiplies it by 2. So we're we're dealing with the original graph. So this is going to be y equals -2 because it was -1 and we multiply that by 2. Okay, so for 14, the diagram shows the part of the graph of that. The curve passes through 310, CDs an asymptote, find P and Q. So we know the vertical asymptote here is x equals 2. So we know the vertical asymptotes when we set the denominator equal to 0. So if we solve this for 0, x minus 2, so we know P is 2. And to find Q, we need to use that point 10, 3, where y is 10 and x is 3. So we would get Q is 10 here. So our function is 10 over x minus 2. The graph of f at x is transformed as shown in the following diagram. The point A is transformed to A prime, which is 3, -10. So you see this bit here is flipped over the x-axis. So this is a reflection over x-axis. And we would write negative f at x because it's making the y's negative. And we could call it g at x. And if they wanted the function, we'd do like that. Okay, so we're going to sketch the curve, but first we're going to find a couple of things. I'm going to actually find the things and then sketch it. So the vertical asymptote is when the denominator is equal to 0. So we've got x is 5 over 2. Horizontal, when it's like this, remember that second bit goes to 0, the 1 over 2x minus 5. Goes to 0, so we have y equals 3. X-intercept, we would make y 0. And then we'd have -3. And cross-multiplying, we'd have -6x plus 15 equals 1. And then we'd have -14. And then 14 over 6. And that's 7 over 3. So that's the x-intercept. Y-intercept is when we make x 0, so 3 plus 1 over -5. Okay, so that's going to be 2 4/5. Okay, so if we do a drawing of this, we have the x-intercept, 1, 2, 3 is here, not x-intercept, sorry, vertical asymptote here. So x equals 5 over 2, y equals 3, 1, 2, 3. This is the horizontal asymptote. We have the x-intercept is 2.8, which is like here. And so this is going to look like that. And then we have the y-intercept. Oh, wait. Sorry, I did that wrong. Sorry. The y-intercept is 2 and 2.8. So it's looking like this. And the x-intercept is 2 and 1/3. So like here. So like that. And then if you want to check out what's going on, you can substitute in x equals 3 into the function. So f at 3 is going to be 3 plus 1 over 6 minus 5 is 1, so 4. So it's obviously up here, so we're looking like that. Okay? All right. 16, we've got f at x is that, where P and Q are in the positive reals. Part of the graph of f, including the asymptotes, is shown below. The equations of the asymptotes are 1, -1, and 2. Okay, so we have, all right. So we have this point, 0, 2, and we have, okay, so just pointing out real quick, P is actually going to be our horizontal asymptote too, because we have lower exponent up top than the 2 below, okay? So P is 2, and then we have minus 3x over, and I can because I've got 2 vertical asymptotes, so I can write x plus 1 and x minus 1. So plus 1 for the negative one and minus 1 for that one. Okay, so then, yeah, we can just distribute this out. And then that's going to be x squared minus 1. So q should be 1. Sorry, equals 1. 17. The function f's defined by that. On the grid below, sketch that. Okay, so, yeah, if we have 9 minus x squared equals 0, we're going to have that x is plus or minus 3. Those are our asymptotes. And then our horizontal should be 0. Oh, this is with graphing calculator. Okay, we'll definitely just put this in the graphing calculator. Hold on. So if you put this in the graphing calculator, I'm just going to graph it like this. If we can do some of this without a calculator too, because you can find the y-intercept. So it's going to be 3 over square root of 9. So it's 1. So there's the y-intercept. And there is not going to be an x-intercept, because if you did 0 equals 3, that's not working. So no x-intercept. And we have our vertical asymptotes here at -3 and +3. And then when you graph it, you can see that it's going like this. It's kind of looking like a weird parabola. The range is clearly y is greater than or equal to 1. And I already did the equation of each vertical asymptote. All right, the function f is given by that. Show that y equals 2 is an asymptote. So that is a horizontal asymptote. So we can do either. So if we do 2x minus 3, and we need to get plus 1. So at the moment, we've got 2x minus 6. So we have to add 7 over x minus 3. And then we can separate the numerator. So we'd have 2 plus 7 over x minus 3. So as x goes to plus infinity or negative infinity, f at x goes to 2. The other way we can do it is if we divide everything by x, okay? All right, so that's AI, double I here. Find the vertical asymptote. Well, I think it's quite clear to see that x equals 3. And triple I, write down the coordinates of the point P at which the asymptotes intersect. Well, that's going to be 3, 2, because the x is 3 and the y is 2. All right, so for B, find the points of intersection of the graph with the axes. So they want the x and y intercepts. So for x-intercept, we have numerator equal to 0. So that's x equals -1/2. And for the y-intercept, we just have f at 0, which is 1 over -3. And hence sketch the graph of y equals f at x, showing the asymptotes by dotted lines. Okay, so here's that. Asymptotes are 2 and 3. Oh no, that's wrong. Sorry. 3 is the vertical. 2 is the horizontal. And we have 0, -1/3. So like there. And we have x is 1, -1/2, sorry. So you can see this is looking like that. And to make yourself comfortable, you can substitute in 4. So that's going to be 8, 9/1. So obviously it's up here, so you can just go like that. Okay. 19, consider the functions f and g, where f is that, g is that. Find the inverse of f. So we need, for A, x equals 3y minus 5. So x plus 5/3 is the inverse of f. Given that g inverse equals x plus 2, find g inverse of f at x. Okay, so we're doing for B, g inverse of f, which is 3x minus 5. So we have 3x minus 5 plus 2. Okay, so that's B. For C, given that f inverse of g is that, solve x plus 3/3 equals to the thing we just had, which is 3x minus 3. So cross multiplying by 3, we're going to have 9x minus 9. And then we're going to have 12 equals 8x. So x is 12/8, or 3/2. All right, so for D, h is f over g. Sketch the graph of h. All right, so for D, we have 3x minus 5/x minus 2. So we're going to have vertical asymptote at 2, horizontal at 3, and we're going to have y-intercept at when x is 0, that's positive 5/2, right there. And x-intercept when the numerator is equal to 0, it's 5/3, so 1.4-ish. So it's looking like this. Oops. And then you can substitute in 3. Oh, it's h at 3. So that's 9 minus 5 is 4/1. So that's obviously here. Okay. Sorry, 3x minus 5 is 0. So x is 5/3, which is 1.67, not 1.4. I just spoke too quickly. All right, so that's DI, and they want it from -3 to 7. Okay, so in this case, 1 to -3, you need to actually find out what h at -3 is, which is going to be -14/-5. And you need to find out what h at 7 is, which is 21/16/5. So this is 2.8 and this is 3.2. So really, we need here, you would not put an arrow. You would just say it ends there, and that's -3, 2.8. And then 3, 4, 5, 6, 7 to here. It stops there, and that's 7, 3.2. And y goes from -2 to 8. Okay. So then you need to figure out when 3x minus 5 over x minus 2 is -2, and when it's also 8. So, all right, hold on. So 3x minus 5 is -2x plus 4. So that's 9, and that's 5x. So x is 9 over 5. Okay, and that's going to be -2. So this stops here. So you want to get rid of that bit. The arrow does not keep going. So that point is 1. So this is 1.8. So this is 1.8 -2. All right, so these are portions of the graph. And then up here, we'd have 3x minus 5 equals 8x minus 16. So we would have 11, 5x, x is 11 over 5, and that's going to be where this is 2.2, and that's going to be at 2.2. This keeps going up, and that's 8. So up to here. And you'd label that. So 2.28. All right, so it's just portions of these graph, and you have to stop on the endpoints. All right, so then that's DI, so we need to write down the equations of the asymptotes. So this is at x equals 2, and this is at y equals 3. Now find the inverse in the equations of those asymptotes. Okay, so our function was, so we have x equals 3y minus 5 over y minus 2, cross multiply. Y is on one side. Factor it out. And divide. So h inverse is 2x minus 5 over x minus 3. And the asymptotes of those, so x equals 3 for the vertical and y equals 2 for the horizontal. Okay, so I've already put in g at x here, and we want to solve when g at x is equal to 0, so we want the intercept, so we need analyze graph 0, and we need the left and the right, so that's one of them, and same thing, left and right. So the answer should be -0.79, 0, and 1.79. Now for B, write down the domain of F and the range of F. So range is all real numbers. Oops. Okay, because, intercepts the horizontal asymptote. The domain, however, is that x can't be the denominator when the denominator is equal to 0. So it's x can't be -0.790, and also x can't be 1.79. All right, for C, the graph has vertical asymptotes at the equations x equals that and x equals b, where a is less than b. So a is obviously -0.79, that's its first vertical asymptote, and b is 1.79, because a is less than b. All right, so for D, the graph has a horizontal asymptote with equation y equals 1. Explain why the value of f at x approaches 1 as x becomes very large. So we have f at x is 2x cubed over g at x, which is x4 minus 2x cubed plus x squared minus 2. And then to that, we add 1, okay? So when if you divide in this fraction everything by x cubed, we're going to have 2 plus 1 over x minus 2 over x cubed. Okay, so basically as x gets really, really, really big, you're going to have 2 over, a big number, okay? And then to that we're adding 1. That's why it's the horizontal asymptote. You don't even really have to do it like that. You could just do it as, because 2x cubed is always going to be smaller than the denominator, x to the fourth and all that, as x gets really, really big or really, really small, okay? So either one of those ways. And then E, the graph intersects the x-axis at A and B. Write down the value of the x-coordinate at A and B. So here I would just do it in the calculator. So I've got the function in there already, and we need to find, well, it's already given us this x-intercept. You just do the 0, and then we'll do the 0 here. So it's A is -1, B is 1.